things around the central atom, it must have 109.5 bond angle. This must have 109.5 bond angle. But the third question is, what atoms are replaced by the electron pairs? So we have to make another structure here, and we're going to replace this atoms with the lone electron pairs. One electron lone pair and this second electron lone pair. Now what are these lone pair going to do is that they're going to push these away closer to each other, and from this 109.5, this OF2 would be more like 104, 105. It's more like 104 to 105. Now this bond angle would be a little less than 109.5. Now the structure of the molecule would be bent. It's not linear, it's not tetrahedral, it's bent because of these two electron pairs. Another molecule we're going to look at is HCN. So first of all, we're going to draw this as the two-dimensional molecule. Now, first question we're going to talk about is how many things around the central atom. There are two things around the central atom. And none of them is a pair of electron. So what does that mean? It means that it would not have any effect on the bond angle here. So this molecule would be looking like this. Simply. There are a bunch of other molecules we can take a look at. So let's just not talk about the structures here. I'm going to write a few molecules here. What you're going to do is you're going to practice these problems just like that. So for your ease, I am going to draw these lone pair of electrons so that you'll find it easier to make the structure. So I am doing this for you. So let's talk about NH4 first. It would not have any electron pair because that electron pair is shared with the H positive. So this molecule would be based on trigonal tetrahedral structure, tetrahedral. And the next is SbH3. So the Sb would have one electron pair and then 3 atoms around the central atom. So it have 4 things around the central atom. And talking about ozone, it have central atom, oxygen, have 3 things around the central atom. So 2 of the things are atoms and 1 thing is the lone pair of electron. And we have here SeCl2, which have 2 things, 2 atoms around the central atom and 2 electron pair, which means 4 things around the central atom. So that would also be based on the tetrahedral structure. Now we're going to take a look at some common mistakes students do in practicing these problems or making the structure of the molecule. So in the next video we're going to learn some common mistakes people do while practicing the Vesper theory.